Okay, so this is the very last lesson in Unit 5, Moles and Stoichiometry. In our last lesson, we determined how to calculate the empirical formula. And actually, we're going to use what we did in the last lesson plus one more step, and we are going to learn how to calculate or solve for the molecular formula given the empirical formula and the molecular mass. So we're going to use some of the skills we learned last time and add another step or two to that. So far we know how to find an empirical formula from percent mass, and we know how to find the empirical formula from molecular formula. So for example, if we're given P5O10, we know that the empirical formula is P05. We just reduced that. But how do we find out the molecular formula from an empirical formula? So I'm going to walk you through an example, and then we're going to do some practice problems. So a compound's 80% carbon, 20% hydrogen by mass. If the molecular mass is 75, what is its empirical formula and what is the molecular formula? So this is the new information that we're being given here. The molecular mass is 75 grams. And we can't use that until we solve for the molecular formula. So basically, first we solve for, the empirical formula. And then the second step that we're actually going to do is we're going to determine the empirical mass. And these are just my Reader's Digest steps. Then we're going to divide the molecular mass by the empirical mass, and that's going to give us a multiple. It's going to give us a whole number. It's going to tell us how many times greater our molecular formula is than our empirical formula. And then lastly, we're going to multiply the multiple. Kind of sounds a little weird. Multiply the multiple across the empirical, I'm going to put EMP formula. So the first two steps are easy. It's just solving for the empirical formula, which is what we've been doing, and then determine the empirical mass. What is the GFM of that empirical formula? And then and the third step is when this molecular mass comes into play. So in this case, we take 75 and divide it by whatever we determine the empirical mass to be. So let's get started on this. So we know we have 80% carbon, so that's the same as 80 grams. And we have 20% hydrogen, so that's the same as 20 grams. Remember, percent to mass, mass to moles, divide by small, times till whole. So we've got 80 grams, and we know that 1 mole of carbon is 12.011 grams. And then our grams will cancel. So we know that this is going to give us 6.66 moles of carbon. And then we've got 20 grams of hydrogen divided by 1.0079 grams of hydrogen. Grams of hydrogen cancel, so 20 divided by that is going to give us 19.84 moles of H. So we did our percent to mass, our mass to moles. Now we're going to divide by small. Our smallest number is 6.66. And that's going to give us 1. And then 19.84 divided by 6.66 is going to give us 2.98. And 2.98 is close enough to 3. So our C to H is a 1 to 3 ratio. So our formula is CH3. So that's everything we've been doing. That's what we did in the last lesson. We calculated the empirical formula given the percent of each atom in the compound. Now we can determine the molecular formula. So the empirical mass of 1 mole of CH3 is what? So you've got 12.011 plus 3 times 1.0079 for your hydrogens. And that is going to give you 15.0347. Probably don't have to include those numbers. We said the molecular mass is 75 grams. We were given that in the problem. So how many times larger is the molecular mass than the empirical mass? Well, to figure that out, we take 75 and divide it by 15.0347. And I get 4.98, which, for all intents and purposes, we need this to be a whole number, is 5 times. 5 times larger. So the molecular mass must be 5 times larger than the empirical formula. So we multiply all the subscripts in our empirical formula by 5. So I'm going to do that over here for you. We have CH3 times 5. So there's an unspoken 1 after the C. So 1 times 5 is 5, so it becomes C5. And 3 times 5 is 15. So C5H15. That is our molecular formula. Okay, so let's do some practice problems. Now, not every problem is going to ask you to do all of the steps. You have to kind of evaluate what you're given and what they're asking you to find. What is the molecular formula of a compound that has an empirical formula of NO2 and a molecular mass of N2O? So, molecular formula, I don't know. Empirical formula, I know. And molecular mass, I know. So actually, in order to continue, I already have my empirical formula, so what I need is my empirical mass. So we need the GFM of NO2. So my empirical mass of NO2 is going to be equal to, let's see, we've got 14.0067 plus 2 times 15.9994, because I've got 2 oxygens. And that's going to give me, for all intents and purposes, 46. So my next step is to take my molecular mass and divide it by my empirical mass. Molecular mass divided by empirical mass is going to be 92 divided by 46, which I can see is 2. So my multiple is 2. So I take NO2 and multiply it by 2, and I get N2O4. And that is my molecular formula, which is what they asked me to find. If I go too fast, again, please feel free to pause me at any time. So now we have a compound that's 50% sulfur and 50% oxygen. Calculate the empirical formula. So I don't know empirical formula, question mark. I know the molecular mass is 128 grams, and then they also want me to try to find the empirical formula. So I have 2 unknowns, but given my percents, I can solve for empirical formula. Remember, percent to mass, so this is 50 grams of sulfur. And this is going to be 50 grams of oxygen. And then we have mass to moles. So I know that 1 mole of sulfur, I look up the GFM of sulfur, and it's 32.065 grams. So my grams cancel. 50 divided by 32 is going to give me 1.559 moles of sulfur. Coming over here to my oxygen, 50 grams of oxygen, 1 mole of oxygen is equal to 15.9994 grams. My grams cancel. When I divide through, I get 3.125 moles of oxygen. Next step, divide by small. So I divide by this. This is my smallest. This is going to give me 1. I divide by that here, and I'm going to get 2. So I know that my ratio of S to O is 1 to 2. So this is SO2. So my empirical formula is SO2. Now I need to find the mass of this. Sulfur, which is going to be 32.06 plus 2 times 15.9994. Just showing you how I'm getting this number. And this is going to give you 64.06. 64.06. So in the next step, I'm going to take my molecular mass, which they gave us in the problem to be 128 grams, and divide it by my empirical mass, which I just calculated to be 64.06. So that means that my multiple is 2. So if I take SO2 and multiply that by 2, I'm going to get S2O4 as my molecular formula, which is the final thing that they wanted. Okay, a compound is 63.6% N, which is 63.6 grams of N, and 36.4% oxygen, which is the same as 36.4 grams of oxygen. Calculate the empirical formula, so we don't know the empirical formula. And then it says list 3 possible molecular formulas. So all I have to do is find my empirical formula and then double it, triple it, and quadruple it. So mass to moles. So 1 mole of nitrogen is equal to 14.0067 grams. Grams are going to cancel, and that's going to give me 4.54 moles of nitrogen. And then for oxygen, I've got 1 mole equal to 15.9994 grams. Grams cancel. When I divide that through, I get 2.28 moles of oxygen. Divide by small, it's going to give me 1. When I divide by small here, that's going to give me 2. Well, it actually gives me 1.99, but that's close enough to 2. So my N to O ratio is 2 to 1. So this is N to O. So that's my empirical formula. So if I double this, one molecular formula could be N4O2. If I triple it, it could be N6O3. If I multiply by 4, N8O4. And that here are 3 possible molecular formulas. Okay, moving on. A compound is 92.3% carbon, which is 92.3 grams carbon, and 7.7% grams of hydrogen. Calculate the empirical formula, so we don't know empirical formula. They told us the molecular mass is 78 grams, and they want us to determine the molecular formula. So again, we have to start by solving for this, then we can finish up. So 1 mole of carbon has a mass of 12.011 grams. grams cancel, and I wind up with 7.68 moles of carbon. And then for the hydrogen, 1 mole of hydrogen is equal to 1.0079 grams of hydrogen. And my grams cancel. And that's going to give me 7.64 grams of hydrogen. Divide by small. And this comes out to be close enough to 1. So it's 1 to 1. So my formula is CH. Now I need the empirical mass of this. So 12.011 plus 1.0079 gives me 13.0189. Remember, it's molecular mass divided by empirical mass. We said the molecular mass was 78 grams. Empirical mass is 13.0189 grams. So I get a multiple of 5.99, which is 6. So CH times 6 gives us C6H6 as our molecular formula. Okay, and the last one, I want you to do the last one on your own. So you're going to calculate empirical formula. You don't know that. So you're going to do your whole percent to mass, mass to moles, divide by small. You know the molecular mass is 162 grams, and then you have to determine the molecular formula. You don't know that. You can check your work when you're all done, because you should get C10H14N2. C10H14N2. So if you don't get that answer, we will talk about it in class. Okay, have a great day.